Space weather! Looking at the sun in 304 angstroms. See this giant filament in the northwest and a sunspot rising in the east. Let's take a look at this huge filament. Been up there for days. Check it out. Talk about giant sheets of ionized helium. That is a big, epic filament right there. And let's take a look at this region over here as this sunspot rises. I think we need some more views. Here's the 171 angstrom view with the magnetic field lines. And here's the 171 angstroms view. Look at the sunspot first. Some serious magnetic loop complexity associated with that. And let's check out the region where this giant filament's located. By the way, there's another active region forming in this area here as it sets to the west. And we did see some coronal mass ejections there. So let's take a look at solarham.net and the LASCO C2. I meant the animation. There's the GIF animation of the LASCO C2. Coronal mass ejection coming out of the east, right there. And let's also look at the magnetogram here. Calling it a plage. Once it gets Earth facing, it will be a sunspot most assuredly. Pardon the noisy cooking there. I am a master chef. I make water every morning with my mad skills. And how about some real-time solar wind? 1 day's worth. You see the triangle keeps bouncing around here. It's the blue pane there, the blue line. Triangle is bouncing back and forth. You don't really see any ongoing coronal hole magnetic connection there. Solar wind density is now at 5.84 protons per cubic centimeter. And we're seeing some perturbations there in the solar wind speed. Just moved to 515 kilometers per second. Let's get some more data at spaceweathernews.com. We don't see any X-ray flares like we did yesterday. We saw a tiny B-class flare. And we see some steepness in the magnetometer again there. We'll be looking at the Gong 2 momentarily to check out the magnetic environment. KP index is up to 3. Here's your electron flux. Some spacecraft charging hazards there around northern, South, and Central America, as well as the Caribbean. And the F2 layer is looking pretty charged. This is an anomalous charged region down here. And we haven't seen 10 megahertz at this time of day for a while. And it's also fairly discharged down here around the South Atlantic anomaly. So F2 layers looking a little anomalous. And there's your auroral forecasts. Spaceweather.com is indicating that 10.7 centimeter radial flux is holding steady at 70. Here's the last frame on the gong too. Now we see there's some magnetic complexity in this region here, and it looks like this area right here is the source. Let me draw that again. Right here is the source of the magnetometer spikes. No real big surprise there. Now we're going to let this play because the incoming sunspot is creating some significant magnetic disturbances here. Draw your attention to this region right here. You can see some polarity switching going on in that region. In fact, that's complicated enough to look at the other plot. Let's look at the synoptic plot view here so you get a little bit of better understanding of what's going on with those magnetic fields associated with that incoming sunspot. It's a shame it's split between two parts. We'll look at this part first, near stereo B. You can see those fields are jumping around quite a bit. And we'll leave links. Moving on. Here's your total electron content forecast. Let that play through. And I would note the South Atlantic anomaly once again. Next, we've got some magnetosphere movies, starting out with your velocity. You would be expecting to see some perturbations in this as a result of a changing solar wind speed. And there you can see some different solar wind speeds coming in, the dark red being the lower speed, and the more yellowish, orangish color being the higher speed. Here's a density. We do see some high density around the magnetotail. And around the day-night terminator. And finally, the pressure. Quite high pressure in the magnetotail there, as well as in the leading edge. All right, moving on. Due to the ongoing geomagnetic pole excursion, we do cover this every day. Here's your geospace ground magnetic perturbations. And we see quite a bit of perturbations. Kind of following the pattern we see most days here. We see bleed out of the South Pole into the South Indian Ocean and the Pacific. And here's your global view. These strong fields over southern Canada there. And we'll let that play through once more there. And we'll head to quakes.globalincidentmap.com here. Before we go on to the current, most recent earthquakes, I would note that if you are in these regions, you need to have an earthquake plan. We're experiencing a massive drought of 6 and 7 magnitude quakes, and we're seeing deep earthquakes in all 3 of those areas. Please have a plan. If you don't have one, have things like a bug out bag. All right, so we got some quakes near Vancouver. 2 of them. This one's a 4.1. We also have a 4.9 in Indonesia. Pretty much smack dab in the middle of the warning area. Again, there's been a drought for 6 and 7 magnitude earthquakes. There's a 4.8 and a 4.7 near Vancouver Island. Here's a 4.5 at 362 kilometers depth near Toba, Japan. So that area should be on alert for a low level 5 at least, because 362 kilometers is a deep quake. Indonesia with a 4.9, Peru with a 4.5 at depth, so, you know, right in the warning area once again. Ecuador with a 4.8, Russia 4.9, 4.5 in New Guinea, Iran a 4.2. Let's just look at that Ecuador quake, and we'll see that it's right on the warning area also. Moving on to volcanodiscovery.com. We see a bit of a volcano uptick here, in that Shivaluch is now producing a 24,000-foot ash plume. So uptick at Shivaluch, Sakurajima, 7,000-foot ash plume there, 7,000-foot ash plume at Dacono, Popocatépetl, possible volcanic ash exhalation, Fuego, 15,000-foot plume there, 15,000-foot plume at Revenador, unable to detect Sabancaya, and a 15,000-foot plume at Planchon Petaroa. Sounds like a volcanic uptick to me, folks. Next, we'll leave links to this also, electroverse.net. Eau Claire breaks February snowfall record already, and it's only the 14th. By the way, happy Valentine's Day, folks. Vancouver receives 3 times its average monthly snowfall in just 3 days, with more forecasted. And as exports increase while production falls, Russia moves to reassert control over the grain market. If you're not familiar with global crop losses, people, follow our endorsed channels. Global crop losses are going to be the thing that breaks down the economy in the next year. The more prepared for it you are, the better. The most recent storm in the Northeast left over 100,000 without power, which is a great reason for you to own a generator, by the way. By the way, this is watchers.news, another great site that people that watch our channel should like. If you're not already familiar with it, check it out. We'll leave links in the description. Next, let's go to sciencealert.com. They're covering an article about how Mars may have volcanic activity, but what we're interested in is new map of dark matter spanning 10 million galaxies. Ooh, look it. It's a map of dark matter. Wow, whoa. Who made it? Anyway, who came up with this map of dark matter? Oh my gosh. An international team of astronomers. I'm going to send them several photographs of my ass so they can make a map of that. Anyway, they've produced the most comprehensive map of dark matter across the history of the universe to date. Oh man. Well, thank goodness. It has yet to complete peer review since dark matter isn't a thing. And since electromagnetic fields are what are governing the movement of these galactic scale objects. Now, these maps are actually useful because they tell us where the electromagnetic fields are located. But They also represent a fundamental lack of understanding of astrophysics. By the way, redshift is not understood right either. And gravitational lensing is not caused by gravity. Sorry to break it to you. All right, we don't want to get too into the weeds here. We'll leave links to that article. Speaking of articles, how about Cosmos Magazine? Now, we've been telling our viewers for weeks that the Large Hadron Collider has been shut down. There's no atom smashing going on in there. There's no particle acceleration happening, folks. However, they're looking at building a new, much larger 100-kilometer size collider. We can't wait till that gets online so that people freak out and post comments about how the collider is causing sunspots. Which, by the way, is not a thing. And of course, we're back to dark matter again. You can't go very far in the world of astrophysics without hearing about dark matter. There was no mention of gravity or solid prediction for the dark matter that holds the galaxies together, and all efforts to explain the dark energy that appears to drive the accelerating expansion of the universe was off by 120 orders of magnitude. That's right, a 12,000% margin of error. And before it's likely, the answer will... As before, it's likely the answer will come only after things get worse, with a more fundamental description of nature that clarifies an ever messier situation. Almost as messier as a Messier object. So we're going to spend $40 billion on the proposed future circular collider. It would be nice if we would spend all this money and allocate resources responsibly instead of wasting it on projects to discover things that aren't there. We will leave links to that article also. Now let's look at some views at 94 angstroms, because this view takes more photos, 5 times more than the other views. First of all, we'll have a look at the setting region where that giant plasma filament's located. Next, we'll have a look at this active region that's forming. Let that play through as that forms. And finally, the rising sunspot region. So, in summary, we're waiting for a coronal hole magnetic connection. We don't see any large coronal holes right now, but if we do get a coronal hole magnetic connection, earthquake risk goes up even higher, as we are in a drought for magnitude 6 and 7 earthquakes, especially in places like New Zealand and Oceania, Indonesia, Papua New Guinea, Japan, and Western South America. Thanks for tuning in. Thanks, subscribers. Thanks for watching. Please press that like button if you enjoy the content. Subscribe if you haven't done so already. We'll be doing it all again tomorrow. Thanks, donors. Thanks, commenters. Remember, when you're staring at the sun at 94 angstroms, don't drink. And if you drink, stare at the sun at 94 angstroms. Just don't drive.